All right, let's talk about inference for deployed models on SageMaker. So inference is the act of requesting and getting a prediction. Once an ML model is trained, it needs to be deployed so you can infer predictions. There are two ways you'd want to deploy for inference. First is real-time prediction, which are endpoints. We want to host our ML model on a server with accessible API endpoint. We can send an HTTP request that the endpoint can get back a prediction. In this case, we use SageMaker hosting services. We have batch predictions, so batch transfer jobs, where we have a large data set and we want to apply predictions. We only need a server for the duration of batch predictions. In this case, we use batch transformation. SageMaker has a whole service catalog for inference, and you can use the SDK in the AWS console to deploy it. This UI is still here, and then there's another UI within the new SageMaker Studio, so just understand that it'll appear in more than one place. Let's talk about inference pipeline. So in Amazon SageMaker model is composed of a linear sequence of 2 to 5 containers that process requests for inference on data. You use an inference pipeline to define and deploy any combination of pre-trained SageMaker built-in algorithms and your own custom algorithms packaged in Docker containers. You can use an inference pipeline to combine data science tasks for pre-processing, predictions, post-processing. You can reuse containers used for data transforms for training. We can use SageMaker Spark ML serving container, scikit-learn container. The first container handles the initial request. Inference pipelines, when deployed, run all containers on ECS. Containers are co-located on the same EC2, and you'll get low latency for inference. Inference pipelines are immutable. You have to deploy a new version for an endpoint. There's no cost inference pipelines. You just have to pay for resources underneath. So here is an inference pipeline where we have multiple sequential containers. We'll need to transform our raw data into expected features using pre-processing. We will run our trained model that will make a prediction. We could have multiple trained models passing on to others. The example is PCA to deep AR. We need to transform our prediction back into a human readable format via post-processing. Okay, so kind of getting all those steps here, if that makes sense. Before training a model, you use preprocessors to transform your data and engineer features. You can use Spark ML jobs and scikit-learn. I keep looking at that thinking that looks like that's spelled wrong, but maybe it's fine. Maybe the Y is missing there. So Spark ML, you can run Spark ML with AWS Glue and SageMaker Notebooks. SageMaker Notebooks is not going to be around forever, but there's SageMaker Jupyter Labs, so it's going to have the same equivalent. So just understand that thing has been marked for deprecation. But when you think of notebooks, we think of Jupyter Labs within the SageMaker Studio. You can also connect to an existing EMR cluster. You can package and serialize Spark ML jobs, things like that. And yeah, that is spelt wrong. It's supposed to say Sci right there. Scikit-learn, you can run and package scikit-learn jobs into containers directly into Amazon SageMaker. Before you can deploy your model, you need to create a model. You can use the Create Model API to do so. There's supposed to be a screenshot here, and it's not here, so it's not a big deal. It's just some code, but yeah, just know that you can use that. There are 3 ways we can apply pre- and post-processing. We have single model. This is where we include pre- and post-processing within our inference script. Then we use TensorFlow service model that has the designated function handlers for pre and post. We have the inference pipeline, so we can create a model out of model containers that run in sequential order. We do not use SageMaker processing, but we create a model using an estimator. And I know this is confusing. It's just the terminology, right? So, it's just the way it works. So, and again, if you're not confused, it's fine. If none of this makes sense, that's okay as well, because if you're doing the AI Practitioner, we don't need to know that level of detail. When we do the AWS Machine Learning Associate, I'll make sure it's very clear, okay? So we have SageMaker pipelines. We can create pre and post processing steps in our pipeline. We use SageMaker processing, and SageMaker processing is only intended to work with pipeline. Let's talk about SageMaker hosting services. This is when you are running your ML model on ML EC2 instance. When you are ready to deploy your ML model for real-time inference, we call on our estimator and then the deploy function. So here's an example. Okay, we specify the ML EC2 instance that we want to utilize. We deploy the function and it will return a predictor, and we'll get a deployable model that launches an EC2 server and configures SageMaker hosting services endpoint. We can get a name of an endpoint by calling endpoint name. Okay, and we'll get some stuff back here. You can make a prediction by using invoke endpoint. Okay, and so we have invoke endpoint as an example. Let's just talk about batch transformation. So instead of hosting an endpoint in production, you can run a one-time batch inference job to make predictions on a test data set using SageMaker Batch Transform. So here we have our estimator and we'll return a transformer, which will specify what ML EC2 instance should be used. We have our output path. We have our transformer where it starts the job. We specify the S3 bucket. And once the job is complete, it creates a file, output path, and you can download the results there. Let's talk about multimodal endpoints. You can save money by hosting multi-models on a shared serving container. Scalable and cost-effective solution to deploy large numbers of models, enable time sharing of memory resources across your models, support A/B testing. They also work with auto-scaling and private link. They work with serial inference pipelines. They work best when the models are fairly similar in size and invocation latency. You can't use multi-model enabled containers with elastic inference. This doesn't even exist anymore, so I'm going to cross that out. When creating models, it ensures it is multiple models. When creating your endpoints, you add product variants. We have multi-container endpoints. This is SageMaker multi-container endpoints, which allows you to deploy multiple containers, deploy different models on SageMaker endpoints. The containers can be run in sequence as inference pipeline, or each container can be accessed individually by using direct invocation, improve the endpoint utilization, and optimize costs. Here's an example of creating a multi-container example. And there's that create model thing we didn't see earlier. Here it is right now. And then we have the multi-container endpoints. So you'll need to specify how you want to invoke them. Okay. Right. And, we're on the model registry. So we're done here. And yes, I went through a lot of stuff there. I'm just trying to get through this course. It's so darn large. And if you're doing the AI practitioner, you just need to generally understand what it is that you're looking at. And so hopefully that gives you an idea. And if this is the machine learning associate, I'll have lots of labs around it, so it's very clear what all this stuff is, okay?